chain and sprocket calculations. I'm just going to do a simple problem here to give you an example of this. Same concept as belt and pulley, same concept as a gear train. An industrial overhead door has a chain and sprocket system designed to reduce the force needed by an operator to open and close the door. The system consists of two individual systems that are connected through a live axle shaft. To operate the door, the operator pulls a continuous loop of chain over a fixed 30 teeth sprocket that is attached to a live axle shaft. So let's draw that real quick. We have up here the sprocket, and then we have this chain dangling down that some person is going to be grabbing a hold of this chain and rotating it, pulling it down with his hands and up like so. It says that the number of teeth are 30. Then it says a second 22-foot sprocket is attached to a live shaft and uses a chain connected to a 51-tooth sprocket that is attached to a drum that drives the door. So you can't see this because I'm not going to try to draw it three-dimensional. Well, I will for a moment, but don't draw this. Behind this 30-foot, or this 30-tooth sprocket, there's another one. And it's attached to some axle, let's say like this. No, I will draw this, I guess. It's the same size, 30-tooth. And then that gets attached to a chain that goes to a sprocket. It is 51 teeth. That's the picture. You could have simply drawn this and it would have been sufficient. Because in essence, this is what's happening. The axle between these 30 teeth don't change the calculation whatsoever. So either of these pictures will do. So what is the overall system gear ratio? Well, gear ratio, number of teeth on the out divided by number of teeth on the in. The output is 51. The input is 30. Using a calculator. Alright, so if you divide 51 by 30, you get 1.7. So that's what the gear ratio is. You could say 1.7, you could say 1.7 to 1. You could actually convert this to 17 to 10. Let's not get crazy here. Let's just say 1.7 to 1.